Okay, 8.3, I want you to go into the book and I want you to fill these in. Basically, we're talking about inverses. And we touched on inverse at the end of the last section. When it comes to an inverse, I'm going to get the identity matrix. So here, when it says show that B is the inverse of A, when I multiply A and B, I better get the inverse matrix. Punch that into your calculator and go ahead and prove that. On the second page here, again, some vocabulary. Go ahead and get that from the book. We want to try to solve this matrix where A times the inverse is the identity. So they want you to find what is that identity. Find that inverse so we can get the identity. So we're going to try to find that inverse. And we can do that with our Gaussian row echelon forms where we're trying to get ones and zeros all over the place. So if I set this up, 1, 4, negative 1, negative 3, it's augmented to 1, 0, 0, 1. These are the coefficients. These are the solutions. So in order to do this, I could do row 2 plus row 1. So that gives me 1, 4, 1, 0, 0, 1, 1, 1. Now I could take negative 4 times row 2 and add it to row 1. Now if I take negative 4 times row 2, that means it's not changing. But 0 times negative 4 is 0 and 1. Negative 4 times 1 and 4. Negative 4 times 1 and 1. And then negative 4 times 1 and 0. Now I have it in the our completely row echelon all the way down to zeros and ones, so that the inverse must be negative 3, negative 4, 1, 1. All right, on 8.3 on page 3 here, you can find an inverse matrix by adjoining the identity matrix and applying the Gauss-Jordan elimination. So from the entire matrix, you can obtain the inverse. So here when I have my matrix and I want to get the identity, I would set it to the identity so I can find the inverse. Sorry, we're trying to find inverse here. I would follow my rules, and what I'd like you to do is I'd like you to come up with the rules, and I'd like you to come up with the rules so that you can find the inverse. Again, every rule step, make sure that you are denoting it so that when you're done, you are getting all of the 1, 0, 0, 0, 1, 0, all of that on the left-hand side, because that will show that this is the inverse, and then this other part is what is actual the inverse to get the identity. All right, so you go through the steps, set up the augmented, set it equal or augmented to the identity, and then solve it down so you can find the inverse of that one. And I'll check it in class. On page 4, if you're asked to find the identity by hand of a 2 by 2, and this will only work for a 2 by 2, what you do is you take 1 over AD minus BC, which is going to come out to be a number, and then you switch your information. So D becomes A, C becomes negative, B becomes negative. That's how you find it by hand. This AD minus BC is what we call the determinant. So in order to find the inverse, it's 1 over the determinant times that specialized matrix. So if you're going to find the inverse of A here, you would take 1 over the cross multiply, subtract the other cross multiply, and multiply it to the matrix of changed A and D, opposite B and C. So that would become 1/4, 2, 1, 2, 3, which is 1/2, 1/4, 1/2, and 3/4. And when you're using your calculator, you do not get to use decimals. You use decimals, it will be marked wrong. On part B here, if I did this, I get 1 over cross multiply, subtract cross multiply, and then the changed up matrix. Notice I get 1 over 0. It doesn't matter. That can never happen. So there is no inverse. All right. On page 5 here, in our systems of equations, we talked about this one again at the last chapter, where we could set our coefficients into matrix A, then our variables, and then the solutions into B. And then we could essentially divide by matrix A. The only thing is in matrices you can't really divide by a matrix, so we do what's inverse. And the inverse always goes in front. You can use your calculator. Inverse times the normal matrix gives you your solution of x, y, and z. So at this point, it's just a lot of calculator. Type it into the calculator. And that's going to be 8.3.